Atomic bomb, also called atom bomb, weapon with great explosive power that result from the sudden release of energy upon the splitting or fission of the nuclei of heavy element, such as plutonium or uranium. This weapon is based on Albert Einstein's theory that relativity between mass and energy, E equal mc squared. E refer energy released from mass with a speed of light, mass with a speed increase, and when a speed close a speed of light, mass converts energy.
Oh God! Oh God! Oh God!
Science has profoundly altered the conditions of man's life, both materially and in ways of the spirit as well. It has extended the range of questions in which man has a choice. It has extended man's freedom to make significant decisions. No one can predict what vast new continents of knowledge the future of science will discover. But we know that as long as men are free to ask what they will, free to say what they think, free to think what they must, science will never regress, and freedom itself will never be wholly lost.
Nuclei consist neutron and proton. When a neutron strikes the nucleus of an atom of isotopes uranium-235 or plutonium-239, it causes that nucleus to split into two fragments, each of these nucleus with about half proton and neutron of original nucleus. In the process of splitting a great amount of thermal energy. So, what thermal energy? Thermal energy neutral energy present in system in a state thermodynamic equilibrium responsible is temperature, as well as gamma rays, and two or more neutrons is released. Under certain conditions, the escaping neutrons strike and thus fission more of surrounding uranium nuclei, which then emit more neutrons that split still more nuclei. This series of rapidly multiplying fission peaks in chain reaction, in which nearly all fissionable material is consumed, in the process generating explosion of what is known as an atomic bomb. Plutonium has 94 protons, 2 more than uranium. It also has several isotopes, with plutonium-239 became most useful in nuclear weapons. Plutonium occurs only in trace amount in nature, but is produced in nuclear reactors when uranium-238 capture neutrons and temporarily become uranium-239. Uranium-239 has a short half-life and decays into Neptunium-239, which decays into Plutonium-239. Plutonium much more stable. The plutonium produced this way is an bomb fuel. Many isotopes of uranium can undergo fission, but uranium-235, which is found naturally at a ratio of about 1 part per every 139 parts of the isotopes uranium-238, undergoes fission more readily and emits more neutrons per fission than other such isotopes. plutonium-239 has these same qualities. These are the primary fissionable material used in atomic bomb. A small amount of uranium-235 cannot undergo a chain reaction and thus form a subcritical mass. This is because, on average, the neutrons released by a fission are likely to leave assembly without striking another nucleus and causing its fission. If more uranium-235 is added to assemblage, the chances that one of the released neutrons will cause another fission are increased, since the escaping neutrons must travel more uranium nuclei and the chances are greater that one of them will strike into another nucleus and split it. At the point at which one of neutrons produced by fission will on average create another fission, critical mass has been achieved. An atomic explosion will result. So, what is critical mass? In nuclear physics, minimum amount of given fissionable material necessary to achieve a starting chain reaction. In practice, an assembly of fissionable material must be brought from a subcritical to critical state extremely suddenly. Critical state, set of conditions under which a liquid and vapor become identical for each substance. One way this can be done is to bring two subcritical methods together, at which point their combined methods become a critical one. This can be practically achieved by using high explosives to shoot two subcritical slugs, fissionable material together in hollow tube. A second method used is that of implosion, in which core of fissionable material is suddenly compressed into a smaller size and a greater density. Because it is denser, the nuclei are more tightly packed and chances of emit neutrons striking nucleus are increased. The core of an implosion type atomic bomb consists of fissionable material surrounded by a jacket of high explosives, which being together detonated, implode the fissionable material under enormous pressure into a denser mass that immediately achieves certically. An important aid in achieving certically is the use of temper. This is a jacket of beryllium oxide reflecting some of the escaping neutrons back into fissionable material, where they can cause more fission. Fission releases an enormous amount of energy relative to the material involved. The detonation of an atomic bomb releases enormous amount of thermal energy or heat, achieving temperature of several million degrees in the exploding bomb itself. This thermal energy creates large fireballs that heat of which can ignite ground fires that can incinerate an entire small city. The detonation also immediately produces a strong shock wave that spreads outward from the blast distance of several miles. Such a blast wave can destroy buildings for several miles from a location of explosion.
We knew the world would not be the same. Few people laughed. Few people cried. Most people were silent. I remembered the line from the Hindu scripture, the Bhagavad Gita, Vishnu is trying to persuade the prince that he should do his duty, and to impress him takes on his multi-armed form and says, "Now I am become death,